Now gradient of AB, m of AB, will equal y2 minus y1, which in this case would be 4 minus 7. Remember, the y coordinates of B is 7, the y coordinates of A is 4, over x2 minus x1, which is going to be 2 minus minus 1, which is going to equal 4 minus 7 is negative 3. 2 minus minus 1 is the same as 2 plus 1, which is going to give me a gradient of positive 3. Negative 3 divided by positive 3 is negative 1. That means my gradient of AB is given as positive 1. The next one I'm going to look at is I'm going to look at my gradient of CD. If I draw CD in over there, let us look at that gradient. Remember, m is equal to y2 minus y1, which is going to be negative 5, negative 5, y2 minus y1 over x2 minus x1, which is going to be 3 minus 3, which is equal to minus 5 plus 5, which is 0, over 3 plus 3, which is 6. 0 over 6 gives me a gradient of 0. Notice something here. This line is parallel to the x-axis because it's got the same y values. The 2 points on the line have the same y values. That means that this line has got a 0 gradient, or rather a 0 degrees slope. And that makes sense, doesn't it? It's not sloped uphill or downhill, it's flat, so it's got a gradient of 0. If it was a line parallel to the y-axis, you're going to find that your change in y is equal to your change in y is going to be something, but your change in x, because it's the same x values, means that your change in x is going to be 0. If your change in x is 0, it means your denominator is 0, which is undefined, which means that for any vertical line that's parallel to the y-axis, the gradient is undefined. Keep that in mind. Alright, the next gradient I'm going to look at, let's go with AD. Let's look at the gradient of AD. Let's do that one in red. We're looking for the gradient of AD. I'm going to erase this. We're looking for the gradient of AD. Change in y over change in x, or rather y2 minus y1 over x2 minus x1. y2 is minus 5 minus y1, which is 4, divided by x2 minus x1, which is going to be 3 minus 2. Minus 5 minus 4 is minus 9. 3 minus 2 is 1, which gives us an answer of negative 9. Now look at this line over here. It's very negatively sloped, which makes sense that it has a gradient, such a high gradient of negative 9. It doesn't matter which points I chose as y2 and y1, or rather as point 1 and point 2, as long as I used uniformity. What I mean by that is, I could, instead of saying minus 5 minus 4, I could have also said 4 minus minus 5, y2 minus y1. But if I chose that as being y2, that has to be x2 minus x1, which will give me an answer of 4 minus minus 5 is positive 9, over 2 minus 3 is minus 1, which is still negative 9. The next gradient I'm going to look at is the gradient of CB or BC. That's over here, from there to there. That's the gradient I'm now going to be looking at. Look at it, it is positively sloping. Not only is it just positively sloping, it's very positively sloping. So you notice that the gradient for AD came to be a very negative gradient. The gradient for BC is going to come to a very positive gradient. Let's have a look at that. M for BC is equal to y2 minus y1, 7 minus minus 5, over x2 minus x1, which is minus 1 minus minus 3, which is equal to 7 minus minus 5 is the same as 7 plus 5, which is equal to 12. 1 minus minus 3 is the same as, minus 1 minus minus 3 is the same as minus 1 plus 3, which is equal to positive 2. 12 over 2 is equal to 6, and that is a fairly steep gradient, as you can see. Now a gradient of 6, in this case positive 6, means that an increase in 1x would be a 6 times increase in 1y. Let us have a look at that. If I take, for example, this point over here and this x value over here, there's a big difference there. But this is only a change of 1 in the x. But look at the change in the y. It's that amount. So a big gradient means that for every 1 increase of x, the y increase is that many times, is the gradient amount of times. So for instance, in this case, an increase of 1 in the x would lead to a 6 increase in the y, because it's change in y over change in x. A fraction gradient, anything below 1, for example 1 over 6, means that an increase of 1y would be accompanied by an increase of 6 in the x. Now we are going to have a look at the midpoint theorem, and you're about to see why analytical geometry is so easy. The midpoint means we are looking for the middle of 2 points. The midpoint theorem looks at a technique we can use to find the middle of 2 points. Let us take a look at that closer. We are now going to look at the midpoint theory. I'm going to use the same graph that I've been using thus far for the gradient. I'm going to now be looking for the midpoint between A and B. Now think about this. The midpoint between A and B would be over there, right? Wouldn't that have an x value and a y value? More importantly, let's look at the coordinates of the x value and the y value. This x value would be exactly between 6 and 3. How do we get exactly between 6 and 3? Quite simple. We add the 2 and divide it by 2. 6 plus 3 is 9 over 2, which is 4.5 or 4.5. And that would be exactly in between 6 and 3. And exactly between 4 and 2 would be the point 3. 4 plus 2 is 6, divided by 2 is 3. That means that the coordinates of M, our midpoint, is going to be given by x1 or x2 plus x1 divided by 2, and our y value is given by y2 plus y1 over 2. The y and the x do not interact with each other. They simply are, or give us, the x coordinates independently and the y coordinates independently of our midpoint.